Welcome everybody to exercise 3 on page 107 of the workbook. And here's another example of an applied problem involving definite integrals. And let's read this question together. So they're giving us the velocity of a biker who's riding up and down a straight east-west highway, where they're giving us a formula for the function right here and a graph of it over to the right. Okay, let's start by maybe reminding ourselves of units here. So we're talking about time in seconds and velocity in feet as you read that problem. And we want to notice maybe what the difference between positive and negative velocity means in this question. Okay, so wherever this velocity function is positive, that means that the biker is moving in the east direction, and where it's negative, we're moving in the west direction. So we'll kind of keep that in mind as we work our way through this problem. Okay, so let's start with part A, which asks us to calculate an integral and then to also explain what that integral means in the context of this problem. So let's just start with the calculation part of it. So we're integrating 0 to 10. Our function looks like 1/50th t squared minus t plus 8. Okay, so to do this integral, we need an antiderivative. And we've got a bunch of powers of t, so we should be able to use the power rule. So we're going to get a 1/50. Antiderivative of t squared is t cubed over 3, just using the power rule. And then antiderivative for t would be t squared over 2. And antiderivative for 8 would just be 8t. Okay, we're going to substitute 10 and 0 in there. Okay, and if we do that, we might notice that we can kind of consolidate this first term into one fraction and maybe write that as 1/150 t cubed. I'm going to use that when I do the calculation over here. So we'll plug in our tens, and that's going to give us a 1/150 times 10 cubed, or 10 cubed over 150. Then we move over to the t squared over 2 and get 10 squared over 2. Plus 8 times 2 is 16, or I'm sorry, 8 times 10. And then you might notice that when you plug in your lower limits, if all of the t's are 0, we're going to get zeros for all three of these terms. So I'm just going to write 0 for that. We don't get anything there. Okay, then it's a matter of figuring out what that number is. It turns out to be about 36.67. And then we come to the question of, what did we just measure there? What are we talking about in this problem? Okay, well, let's think units here for a minute. Okay, so our function that we're integrating, they told us that that's a velocity, so that's going to have units of feet per second. And then time, dt, is going to be measured in seconds. What do you get if you multiply those two units, feet per second times seconds? Well, the seconds cancel and we get feet. And so the answer that we got has something to do with a displacement. That's not surprising when you think about the total change theorem. We integrated a rate of change, a velocity, and we got total change in position. Okay, so in words, we could just state this something like the following. Between 0 and 10, we can see from the graph that the biker is always moving to the east, and that just measured that eastward displacement that we got. Okay, so we'll say it this way, indicates that the biker is 36.67 feet east of home after 10 seconds. Okay, there's our interpretation to go with our answer. Okay, we can maybe make one other comment here. What did we graphically calculate here? Well, this 36.67 is the integral from 0 to 10, so you could think of it as the shaded area, which I'm going to call A1. Okay, that's a little bit hard to read with all that shading there, so let me try that again. Okay, so I'm going to let A1 be that area that was shaded just a minute ago. Okay, there's our answer to part A. So let's move on then and look at part B. It's asking us a similar question. It's giving us another integral and asking us to interpret that. Okay, so this calculation is going to be similar to the one that we just did. Okay, we're starting with the same function. Okay, so the antiderivative is going to be the same. That part's not going to change. We don't need to do that calculation again. The antiderivative is still going to be t cubed over 150 minus t squared over 2 plus 8t. The only thing that's different is the limits that we're plugging in. This time it's 40 and 0. Okay, and if we do that, let's see, we're going to get 40 cubed over 150 minus 40 squared over 2 plus 8 times 40. And just like before, the lower limits are all going to go to 0. And you can confirm by just substituting these numbers into your calculator. This time you're going to get a negative 53.33. Units are still feet. And what does that number mean? Okay, well, the fact that that number is negative means that we have to be careful how we phrase this answer. It would not be accurate to say, for example, that negative 53.33 feet is the distance traveled, because distance can't be negative. Okay, so what does that negative 53.33 really mean? Okay, well, we can maybe go back to the graph to get some insight into that. So if we integrate all the way from 0 to 40, we're going to start by integrating 0 to 10, okay, which is going to give the a1 that we already found from part A. But then we're going to continue on between 10 and 40, and that's going to be about the area down here that's below the x-axis. So graphically, what this represents is the area a1 minus a2. Okay, conceptually, you can think of it maybe this way. This biker moved east between 0 and 10, a particular distance, then moved west between 10 and 40, a particular distance. And so what we're really looking at here with this negative 53.33 is a net change in position, just telling us that we wind up a little bit farther to the west than where we started. Okay, so we could maybe make our explanation reflect that observation. Okay, so this calculation indicates that the biker is 53.33 feet west of the starting point after 40 seconds. Okay, so it just represents a net change in position. The negative sign is indicating direction. We wind up farther west. Okay, and then we come to the most interesting question of all of these, I think. What if we wanted to calculate the total distance traveled between 0 and 40? We already talked about how our answer to part B is not the distance because it's a negative number. So what do we do if we want to get the distance? Okay, well, we can get some graphical insight into that by just scrolling up again. What we really want to do to get the total distance traveled is to start by, well, we can maybe think of it in two parts. There's a portion of this time interval where the biker is moving to the east, that's this A1. And there's a portion where the biker is moving to the west, that's A2. And instead of subtracting those two numbers, like the answer to part B did, we just want to add them. Okay, so what we'll do is break that calculation into two parts and say that the total distance, graphically, is A1 plus A2, which in words would just be the distance traveled east plus the distance traveled west. Okay, we'll do two separate integrals to get those. So the distance traveled east between 0 and 10, that's the A1, is just going to be the integral of v of t from 0 to 10. And then we want to integrate from 10 to 40, but our function is negative on that interval. So if we just took the integral from 10 to 40, we'd get a negative number. We don't want a negative number then. So we're going to cheat a little bit and just stick a minus sign in there to make that number positive because it's distance that we're after here. Okay, so we can do this calculation. We've got an answer, and notice that the first part of it, that integral from 0 to 10, we already calculated that in part A. We know that that's 36.67. The only new calculation to do is the second part, integrating our function from 10 to 40. And antiderivative of v of t, we've already calculated that a couple of times. It looks like this. Okay, we just need to substitute in our 40 and our 10, see what we get, and add everything together. So let's see what happens here. So plugging in 40 for all of our t's is going to give us that. There's our upper limit, and our lower limit this time is 10. Okay, and that's a lot of writing. And at this point, you'd probably go to your calculator, and I'm just going to show you what this should end up being. You can check my calculations here. 36.67 minus. And if you do all of this calculation in the brackets, what I'm hoping you'll end up with is a negative 90 there. So 36.67 minus negative 90, that works out to be 126.67 feet. And that should be the total distance traveled.